All right, we're doing a handout today. Should hopefully I'll be able to find it and get it to y'all. Science of heat. Short read, 10 questions, okay? All right, heat is a transfer of energy from one object to another due to the difference in temperature. Heat can be measured in joules, BTUs, British thermal unit, or calories. Again, that's what, when you burn off energy, you're burning off calories. Heat and temperature are closely related, but are not the same thing. The temperature of an object is determined by how fast its molecules are moving. The faster the molecules are moving, the higher the temperature. We say objects that have a high temperature are hot, objects with a low temperature are cold. All right, I know, that's an eye-opener, isn't it? Okay, transferring heat. We talked about this last week. When two items are combined or touching each other, their molecules will transfer energy called heat. They will try to come to a point where they both have the same temperature. Okay? This is what we have talked about off and on. This is called equilibrium. Heat will flow from the hotter object to the colder object. Remember the drink and the ice, okay? The molecules in the hotter object will slow down, and the molecules in the colder objects will speed up, okay? And eventually they will get to the point where they have the same temperature, and that's equal. They're equilibrium at that point in time, okay? This happens all the time around you. For example, when you take an ice cube and put it in a warm soda, the ice cube will become warmer and melt, and the soda will cool down because it is transferring its energy to the ice cube because it's trying to warm that ice cube up, okay? And by doing so, it's transferring some of its energy to the ice cube. The ice cube is warming up and melting, but because the soda is giving away energy, it's cooling down, okay? Okay, hot objects expand. When something gets hotter, it will expand or get bigger. At the same time, when something gets colder, it will shrink. Okay, it will actually go down in size a little bit. This property is used to make mercury thermometers. Okay, back in the old days, that's how they used to make, and they still do for the big weather stations and things like that. They still use mercury. Today, if you actually had an oral thermometer, it's probably got alcohol. So like a rubbing alcohol almost in it with food coloring in it. The line in the thermometer is actually liquid mercury. As the liquid gets hotter, it will expand and rise in the thermometer to show a higher temperature. It's expansion and contraction due to temperature that allows the thermometer to work. And think about it, the reason it goes up and back down, it's in a glass tube, right? So it's kind of captured. So when it gets hot, it's going to move. So because it's in that tube, that's why it goes up and down. If you had it just laid out on a table, it would just expand, in and out another way. If it wasn't in a container. Okay. All right. Heat conduction. When heat transfers from one object to another, this is called conduction. Some materials conduct heat better than others. Okay? Metal, for example, is a good conductor of heat. We use metal in pots and pans to cook because it will move the heat from the flame to our food quickly. So it warms our food up quicker because it conducts the heat. Okay? Plastic, not such a good conductor of heat, right? It's going to melt. Wood, not a good conductor of heat. It's going to burn up, okay? But metal will actually just take the heat and conduct it into the food, move it to the food. Cloth, like a blanket, is not a good conductor. In fact, what do we call, remember Friday we talked about this, what do we refer to a blanket as? An insulator. Yes, an insulator. Okay? So a blanket is not a good conductor of heat because it's not a good conductor. A blanket works well to keep us warm at night, okay? As it won't conduct the heat from our body out to the cold air. That's how a blanket works, okay? You're sitting on the sofa, maybe you're a little bit chilly, and you get a blanket and pull up over you. What's happening is your body is giving off heat, right? Well, that blanket acts as an insulator, and it's not allowing your heat to just escape out into the air. It's keeping it in, and by keeping it in now, it's warming you up. Okay? That's how that works. You probably already knew that, but there we go. Okay? Matter changing state. Heat has an impact in the state of matter. Matter can change state based on heat or temperature. And of course, the three states of matter can depend on its temperature. Solid, liquid, and gas. For example, if water is cold, then the molecules are moving very slowly. So that would make it ice, which would be a solid. Okay? If it warms up, the ice will melt and become water. That becomes a liquid. But when it gets really, really hot, okay, you keep warming the water up until it starts to boil, okay? Now it's moving really fast, and you start seeing the steam come up off of it. It's evaporating, and it is becoming a gas, okay? So it's because now it's gotten really, really hot, so it's become a gas, okay? Everybody understand that? Because I believe that is one of the questions on your homework. All right. Well, that was easy and quick. Short class today because of ERBs again. So, there you go. About 6.5 minutes of seeing my lovely forehead. Bye-bye.